Hi there, my name is John Nikoloff. Today I'd like to talk about objective functions within flow simulation, design of experiments, and optimization. More specifically, we will be going into more depth into what is going on with our minimize and maximize functions for objective functions in our design of experiments. After we have run our flow simulation, we have our basic flow trajectory showing some basic input data. Now, if we want to optimize our goals, say we already opened these guys and we just want to see the average value. Okay, so we have negative 579 foot-pounds in the negative y direction and 248 foot-pounds in the negative z direction. And that's basically the interacting forces being seen by these faces. So that's great. But if we want to optimize the study, we can go into our projects, right-click it, and click New Parametric Study. From here, we will have a window that will open up a couple options, but we are interested in the design of experiments and optimization. Here, we will be able to click our moving dimension, basically to open and close the top aileron. And we'll be able to change this from 0 to 57 degrees. And this will help us give a range of values so we have a better idea of what we are optimizing per goal. Select our goals here for our output parameters. And for our scenarios, we're going to find the optimum, and I'm going to expand this window so we can get a better idea of what is going on. So here we have our minimize, maximize, and target. This is a great way to explain how we will be approaching our optimized number. So if we choose minimize out of a graph, we will be going for the objective number that we will specify when we click to add our constraints. And these values will coincide with what goal we are going to optimize. So say, for example, let's minimize this equation. And even though our downforce needs to be as high as it can be, and it's a minimum, we actually only need to put a minus sign to make it into a maximum. This essentially says around whatever value we're going to specify, find the maximum value around that value, and vice versa for our drag force. Find the minimum value around our target. Where do we specify our target, you ask? Our constraints. So say we want to do the downforce first. Let's say we really don't think 550 or so is enough. Let's say we want it to be around 700. All we have to do to make this number represent our goal is changing the weight from a 0 to a 1. And that's it. And for our drag force, we will see if we can get that to negative 150, and we'll put that weight to 1. So now, if we look at our equation down here, we are saying our negative downforce is going to be maximized, our drag force will be minimized, and we are looking for a downforce that will be around or less than the value of 700, negative 700. However, we will see data that will show values above this. So now that that is good, we can select how many scenarios we want to create, and this will spit out different values that will basically say, okay, our top aileron is now opened 38 degrees, 19 degrees, 12, 0, and so on. And from here, we will run our study. After we have ran our design of experiments, we can now go back into our find optimum option, and we can add our optimum design point. This will find a value that will get close to, say, looks like experiment 9 was the closest one to this, but we have negative 200, about negative 250 foot-pounds in our z direction and 700 foot-pounds in our y direction. Excuse me, it looks like we're using newtons. And we can run just this study to see if this is a good value, and we will do that now. So here we have our optimum study now finished running, and if you'll notice, 241 newtons in the negative z direction is definitely not less than 150, it's certainly more. That is because the SOLIDWORKS design engine for objective functions is going to ideally find a less value than this. However, if it can't, it will find the thing that is closest to this. This has been John Nikoloff with a quick tip for SOLIDWORKS Flow Simulation, Design of Experiments, and Optimization. Thank you.